circular coil. Two concentric circular coils C1 and C are placed in the XY plane. C1 has 500 turns and a radius of 1 cm. C2 has 200 turns and radius of 20 cm. C2 carries a time-dependent current IT is equal to 5t square minus 2t plus 3 amperes, where t is in milliamps. The EMF induced in C1 in millivolt at the instant t is equal to 1 second is 4 by x. The value of x is the value of magnetic field due to coil 2 is mu naught I2 into N2 upon 2R2. The magnetic flux induced in coil 1 is equal to N1 B2 pi R1. We will put in the value of B2, so we get N1 N2 mu naught I upon 2R2 by R1. Now we will simply put in the given values to find the flux. 500 into 200 into 4 pi into 10 power minus 7 into 5t square minus 2t minus 3 pi 10 to the power 2 square upon 2 into 20 into 10 to the power minus 2, which is 10 to the power 5 into 4 pi square into 10 to the power minus 7 into 5t square minus 2t plus 3 into 10 to the power minus 4 and 40 into 10 to the power minus 2. So the magnetic is 5t square minus 2t plus 3 into 10 to the power minus 2. The EMF induced in coil 1 is d phi by dt, mod of d phi by dt, which is 10t minus 2 into at the instant of t is equal to 1 second. The EMF is 8 into 10 to the power minus 4, which is 0.8, which is equal to 8 by 10 millivolt or 4 by 5 millivolt, which is equal to 4 by x. So x is equal to 5.